Cloud VPN securely connects your on-premise network to your GCP VPC network through an IPsec VPN tunnel. Traffic traveling between the two networks is encrypted by one VPN gateway, then decrypted by the other VPN gateway. This protects your data as it travels over the public internet, and that's why Cloud VPN is useful for low volume data connections. As a managed service, Cloud VPN provides an SLA of 99.9% service availability and supports site to site VPN, static and dynamic routes, and IKE version 1 and IKE version 2 ciphers. Cloud VPN doesn't support use cases where client computers need to dial in to a VPN using client VPN software. Also, dynamic routes are configured with Cloud Router, which we will cover briefly. For more information about the SLA and these features, see the links section of this video. Let me walk through an example of Cloud VPN. This diagram shows a simple VPN connection between your VPC and on-premise network. Your VPC network has subnets in US East 1 and US West 1, with GCP resources in each of those regions. These resources are able to communicate using their internal IP addresses because routing within a network is automatically configured, assuming that firewall rules allow the communication. Now, in order to connect to your on premise network and its resources, you need to configure your Cloud VPN gateway, on premise VPN gateway, and the two VPN tunnels. The Cloud VPN gateway is a regional resource that uses a regional external IP address. Your on premise VPN gateway can be a physical device in your data center or a physical or software based VPN offering in another cloud provider's network. This VPN gateway also has an external IP address. A VPN tunnel then connects your VPN gateways and serves as the virtual medium through which encrypted traffic is passed. In order to create a connection between two VPN gateways, you must establish two VPN tunnels. Each tunnel defines the connection from the perspective of its gateway, and traffic can only pass when the pair of tunnels is established. Now, one thing to remember when using Cloud VPN is that the maximum transmission unit, or MTU, for your on premises VPN gateway cannot be greater than 1460 bytes. This is because of the encryption and encapsulation of packets. For more information about this MTU consideration, see the links section of this video. I mentioned earlier that Cloud VPN supports both static and dynamic routes. In order to use dynamic routes, you need to configure Cloud Routers. Cloud Router can manage routes from a Cloud VPN tunnel using Border Gateway Protocol or BGP. This routing method allows for routes to be updated and exchanged without changing the tunnel configuration. For example, this diagram shows two different regional subnets in a VPC network, namely test and prod. The on-premise network has 29 subnets, and the two networks are connected through Cloud VPN tunnels. Now, how would you handle adding new subnets? For example, how would you add a new staging subnet in the GCP network and a new on-premise 10.0.30.0/24 subnet to handle growing traffic in your data center? To automatically propagate network configuration changes, the VPN tunnel uses Cloud Router to establish a BGP session between the VPC and the on-premise VPN gateway, which must support BGP. The new subnets are then seamlessly advertised between networks. This means that instances in the new subnets can start sending and receiving traffic immediately, as you will explore in the upcoming lab. To set up BGP, an additional IP address has to be assigned to each end of the VPN tunnel. These two IP addresses must be link local IP addresses, belonging to the IP address range 169.254.0.0/16. These addresses are not part of IP address space of either network and are used exclusively for establishing a BGP session.